Hi folks, my name is Syed Jaffrey and I'm a solutions architect here at AWS. I'm joined today with Chaitanya Hazare, a senior machine learning solutions architect at AWS, and also Chris Hausler, head of machine learning at Zendesk. So we're going to talk about how you can scale SageMaker hosting to thousands of models using multimodal endpoints. Let's take a look at the agenda. We'll talk about why you would want to use SageMaker multimodal endpoints and what they are. We'll take a deeper look into how they work. You'll hear lessons and learnings from the field on how to optimize them. And you'll also get to hear Zendesk's story on high-scale machine learning. Now, to understand multimodal endpoints, let's look at them from the perspective of a SaaS business. In a SaaS business, multi-tenancy and cost efficiency play a significant role in the success of that business. You're always aiming to optimize the reuse of the application and the application infrastructure across many of your SaaS customers. Now, the challenge comes with machine learning, because in machine learning, multi-tenancy can get complex. You may need to support variations in your models. Maybe because your customer has the nature of the business of your customers, or perhaps the geography of your customer. We actually see a number of organizations that have a collection of models, 10, hundreds, even thousands of models. What about a scenario where you need to predict a house price by a city? Or perhaps you need to make compliance-related predictions based on a jurisdiction or a country. Or perhaps you need to have per-user models because you want to predict the next best action for a given user. So the question is, how do you hit that Goldilocks just right balance between being able to support all this variation in your models and also maximizing the reuse of your infrastructure? And this is where SageMaker multimodal endpoints really come in to solve the problem. From a cost optimization perspective, take this example. If you have 10 models, by default, you'll have 10 individual endpoints. Now, if you were to consolidate these 10 models into a single multimodal endpoint, then the cost of hosting goes down from a few $1,000s to a few $100s. And you can scale that to thousands of models. Let's take a look at how multimodal endpoints actually work. So you start off by designating a place in S3 where you store your models, and you associate that to a multimodal endpoint, and then you start the endpoint. Now, as your application makes invocation requests on your models, multimodal endpoint loads those models from S3 into memory and then serves them to make prediction. Now, because of this architecture, you can actually also add new models on the fly to the endpoint while it's still running, and that new model can start making predictions. Now, there are some design considerations that you should be aware of. Firstly, remember that models are lazy loaded onto the endpoint. So expect a cold start latency on the first invocation. But we'll keep your frequently used models in memory, and they end up having the same performance profile for latency as if they were hosted on a dedicated endpoint. And we'll evict least used models via an LRU algorithm out of the memory so that we maximize the number of frequently used models that are being served out of memory. And as I said earlier, you can actually add new models on the fly as you need them on the endpoint. And finally, you can configure a no cache on the endpoint. Now that will allow you to serve even more models from the endpoint resources, but here you're trading off latency for cost efficiency. Now let's look at a demo of how multimodal endpoints work and also how they scale.
For this demo, I'll be using the Amazon SageMaker Multimodal Endpoints XGBoost notebook. It's available from the AWS Lab GitHub repo. So this notebook basically has one model per city to predict the house prices for that city. And we'll be using the first 4 cities here in our multimodal endpoint example. So I'm going to go ahead and fast track the setup and training of these models. Okay, so now that training is completed, let's go ahead and create a multi-model endpoint. So the first thing I need to do is to create a model definition from one of the estimators that I trained in the previous steps. Now that I have that, the next thing I'll do is create a S3 location for where the model artifacts will be available for multi-model endpoints to load. So I'll set that in that variable. And then the next thing I'll do is to create a multi-model endpoint definition. And I do that by creating an object here, and I'll give it a model name and the prefix where the S3 location is for the endpoint for the models, as well as the model definition. Okay, so now we have the definition. We go ahead and call the deploy method, and we deploy that multi-model endpoint. We give it the number of instances to start with, the instance type, and the endpoint name. Okay, so now if you move to the SageMaker console, we can see that endpoint is now provisioned. And I'm going to open up the definition of that multi-model endpoint. And what I'll notice is that it currently has a single instance behind it. So I'm going to set up auto-scaling on that endpoint and a maximum of 4 instances to be spun up as part of the auto-scaling event. The metric that I'm going to use is the invocations per instance, and that'll be 10 invocations per instance per minute that will trigger the auto-scaling event. Okay, now that I've set that up, let's go back to the notebook and continue configuring the multi-model endpoints. Okay, so if I list the models that are associated with this endpoint, you see that I have none at the moment, and that's because I need to add and associate models to this multi-model endpoint. And that's done by calling the add model method. So I'm going to go ahead and add the New York, Houston, and Chicago, these 3 models, into the multi-model endpoint that I just created. Okay, so now that they've been added, if I now list the models again, I can see that these 3 models are now being served by the multi-model endpoint. So now we go ahead and make invocations to those models to get the predictions. So the first one I'm going to invoke is the Chicago model. And I'm going to invoke it twice, just to show you the latency from the first and the second. So as you can see that the first time around and the second time around, the second time the latency was a lot less than the first one, and that's because a multi-model endpoint is loading the model from S3 for the first time, hence the cold start. And if I do the same thing for Houston, you'll see that the first time the latency is higher, but the second time around it's a lot less, because the second time around is being served from memory. Now let's go ahead and add the fourth model dynamically while the endpoint is still up. So I'm going to add the Los Angeles model into the endpoint using the add model method, and I can then invoke it straight away. Okay, as you can see, it's making those predictions. The next thing I want to show you is how the multi-model endpoint auto-scales. So for that, I need to generate some load on the endpoint. So I'm creating a Python function that essentially does the same thing as previous steps, which is to invoke the endpoint for a given city. So I'm going to just test that and make sure it works. I've invoked it for Chicago. It's returned okay. And now I'm going to create load, and by calling all 4 of these models multiple times in quick succession, and see how the multi-model endpoint starts to auto-scale based on the request per second per minute metric. So if I go back to the endpoint and look at the invocation metrics, and look at the invocations per instance metric specifically that's linked to auto-scaling, you'll see that there's an alarm, CloudWatch alarm that's triggered. And that alarm is mentioning that there's more than 10 invocations per instance detected per minute, and as a result an auto-scaling event has kicked off. And you can see that also that the endpoint is now in an updating status. So if you scroll down and have a look, the desired instance count has now gone up to 4, but the current instance count is still 1. That's because the endpoint is still updating at the moment. Now, while this endpoint is in auto-scaling mode, it remains active for any existing or current invocations. So if I go back to my notebook and invoke the Chicago model again, you'll see that it returns just like before. So during the auto-scaling event, your endpoint is still available and live for your application. So we'll just go and wait for the endpoint to finish auto-scaling. So now that it's back in service, I can now scroll down to the configuration, and I can see that the current instance count is now 4 since it's completed the auto-scaling. So that's the end of the demo. I will now hand over to Chaitanya to talk about the lessons learned and optimizations.
Thanks, Syed. So now that we have seen multi-model endpoints in action, let's take a quick peek at some lessons we learned from the field, where we see Zendesk and other customers use multi-model endpoints to host thousands of models at scale. One particular area of interest for customers is what are the knobs that affect performance or throughput of a multi-model endpoint. But first, how do you know if performance is improved or not? Towards that, we use a metric published by SageMaker to CloudWatch under invocation metrics called invocations per minute. Here we can see before and after graph. The invocations per minute stabilize at 11,000 in an unoptimized endpoint, and after optimizations stabilize at 44,000 invocations per minute. This is a good indicator of improved performance. To tune performance for your multi-model endpoint based in either TensorFlow or PyTorch, you have the following variables or settings or knobs. Interop parallelism threads. This variable determines the number of threads used by independent non-blocking operations. Intra-op parallelism threads. This determines the number of threads that can be used for certain operations like matrix multiplication and reductions. OMP num threads is used to control the number of threads spawned per CPU core. MMS default workers per model controls the number of threads doing inference per model. In our experiments, tuning these variables with respect to the number of cores within an endpoint maximizes the performance of an endpoint. For example, let's say for an MLC5X large instance type with 4 vCPUs for hosting an NLP model, setting OMP num threads to 1 and workers to 1 gives us 3.4 TPS. OMP num threads to 1 and workers to 16 gives us 3.5 TPS. But OMP num threads to 8 and workers to 16 gives us 15 TPS. Similarly, in our experiments with TensorFlow op variables, we found that for certain models, setting interop to 1 and intraop to 4 gave us the best results. Now, let's take a quick look at how do you make sure your models are loaded onto the endpoint before first invocations that matter are made. This is yet another way to improve the performance of your endpoint. As we saw in Syed's presentation, that for a multi-model endpoint, a model is invoked. If a model is invoked for the first time, it is downloaded from S3. To amortize this cold start, you might want to run a few invocations against an endpoint to warm up the endpoint. This helps to load up the model and keep it ready for future invocations. Now, let's take a quick look at some metrics that an endpoint publishes. These metrics allow you to monitor a SageMaker multi-model endpoint. model loading wait time gives you the interval of time that an invocation request has waited for the target model to be downloaded or loaded or both in order to perform inference. Model unloading time is the time taken to unload the model. Similarly, model loading time is the time taken to load the model in memory. Model downloading time is the time taken by the endpoint to download model from S3, and model cache hit is the number of invoke endpoint requests sent to MME, sent to multi-model endpoint, for which a model is already loaded. Model cache hit is actually the metric that you want to check to figure out if a model has already been loaded in memory and is being inferred against. So now that we have checked all these metrics, let's check out a final tweak that can help us optimize the performance further. Intel Math Kernel Library is a library of optimized math routines for science, engineering, and financial applications. Usually, enabling and using Intel MKL speeds up inference, but we have found empirically in certain use cases, disabling Intel MKL helped us improve the performance by almost 30%. Since this is an easy experiment to perform, please do check out this portion. Please do check out this option in your performance optimization workflow. And with that, let me invite Chris, Director of Machine Learning, Zendesk, to share Zendesk's machine learning story.
Thanks very much. So as Chaitanya mentioned, my name is Chris, and I lead the machine learning organization at Zendesk. And today I'm going to talk to you a little bit about our journey building machine learning features at Zendesk, how we use them to improve the customer experience for our customers and how they serve their customers, as well as a little bit about how we've been using SageMaker and particularly the multi-model endpoints to help make that a reality at scale in production. So for those of you who don't know, Zendesk is a software as a service company, and we make support, sales, and customer engagement software for everyone. I think the thing that we really pride ourselves on is that it's, Zendesk as a piece of software is beautifully simple and incredibly quick and easy to implement. So it takes hours, not days, to get up and running. And there's more than 170,000 companies worldwide who use Zendesk to support their customers and provide a great customer experience with our software, with our product. So we've been building machine learning features for a number of years now. I think the first one that I was involved in was called Satisfaction Prediction, and that was way back in 2015. And at the time, machine learning was a very different, I guess a very different field to what it is now. It's moved incredibly quickly over the last 6 or 7 years. And in particular, the technology around natural language processing has moved really fast as well. So at the time, the first feature that we shipped was called Satisfaction Prediction. At a high level, basically the idea behind Satisfaction Prediction was giving support agents the ability to understand right from the outset whether a customer that they're serving is having a good or bad experience, and giving them the information required then to intervene. So we could predict whether the customer is having a bad experience and allow them to then jump in and turn that around so that the outcome for all of their customers is a great customer experience. And so at the time, machine learning, NLP, a lot of it was really working around scikit-learn was the thing that we went to. It was a lot more classical machine learning than what we see these days with deep learning and so forth. And the way we built this out was to build thousands of very small models. So for us to make machine learning effective at scale, we often need to build models per account for our customers, because our customers have different data. They might use the product in different ways. So when we're building classification models, we're really thinking about, how can we make this work best for each of our individual customers? So what that means is we need to scale out model building, automate model build pipelines, and we were hosting these scikit-learn models, which were quite small from a memory perspective, in-house, using something very simple like a Flask server with an LRU cache to allow for efficiency, to allow us to load and unload models as needed. And that was incredibly effective, and it allowed us to get this product out to the world and out to production. But I think the world has changed a lot since then, and one of the really big shifts that we've seen over the last few years is the rise of deep learning, particularly in NLP. So I think back at at that stage, and deep learning was really gaining traction in the computer vision field. But what we've seen over the last couple of years is also great leaps forward in how deep learning can be applied to NLP, whether that's for language understanding, classification, language generation. And so with that came a technology shift, and we saw scikit-learn maybe not being used as much internally for us, and TensorFlow really taking the main stage as far as the technologies that we were using. And as a result as well, the TensorFlow models we were building, the language understanding models we were building, got really large. And so that was a big difference to what we'd seen with the scikit-learn models. And we were very early adopters of using SageMaker to host these large neural nets in production. So in general, the field was moving forward really quickly, and the technology that we saw coming out was also moving along with it. But there was one notable shift, is that we went from having lots of small models to now having to potentially have lots of really large models. And that building customer-specific models, so models for each of our individual customers that were really large, became a really arduous and expensive task. Because we now needed a lot of memory, a lot of compute resources to make that go. And I think this is, so what that meant in practice is that we shifted from account-based models to building global generalized models for all of our customers, and with the trade-offs that entails. And so one of the really, I think one of the really impactful things that the multi-model endpoint for SageMaker has brought out for us is it's allowed us to balance this idea of having many large models in production and serving those for our customers. So it's, to what Syed was saying earlier on in the talk, it was really a win for cost efficiency and scalability for us, because instead of having to stand up many individual endpoints to host all of these models, we were now able to support thousands of large neural nets in production and scale those. And so that's been a huge shift for us, seeing that functionality come to SageMaker over the last couple of years. And it's really, it helps us to help our customers serve their customers, right? To build better product. And so maybe I'll just walk you through a feature that we're working on at the moment, and so you can get a feel for how the multi-model endpoints have really helped us to get this feature to production and get it out in front of our customers and help them on a day-to-day basis. So a feature that we're building at the moment that is currently in open beta is called suggested macros. So maybe a little bit of context, so you get an idea of what this feature does and why it's important. So within a support organization, support agents are often answering very similar questions that come in frequently. Things like, how do I reset my password? How do I update my shipping address, and so forth. One approach to this is to allow support agents to use what we call macros. They're like little shortcuts or automations that allow the agent to effectively, automate a repetitive task. So in the examples that you can see here on the right-hand side, we have macros for return item guidelines or mailing and shipping. And so you can imagine, for example, the return item guidelines, when you apply that macro, it might fill out, a reply to the customer saying what the guidelines are for returning items, send it back to them, and potentially assign the ticket to a support agent group that deals with returns. So macros were a really powerful tool to help get consistency and speed and efficiency for your support organization. But there's two main challenges with macros as a feature. One is that if I am a new support agent joining a company, I don't know what all of the macros are, and it's going to take me time to learn what the right macro is to apply to a particular ticket. The other issue is for some larger companies that maybe have a very large product surface area. They might have hundreds, maybe even thousands of different macros to deal with, like all of the frequent cases that come up for them. And so in that case, understanding what macros are available and discoverability of those can also become a little bit of a challenge. And so this is where suggested macros comes in. So the idea behind suggested macros is that we learn from previous experience of which macros have been applied to which support tickets, and build a classification model that can then suggest to a support agent when they're on a new ticket which are the appropriate macros to apply. And so in this case, you can see here the suggested macros are around return item guidelines and mailing and shipping for a fictitious ticket that we can't see. And so in building this out, we need to go and build a classification model per account. And so there's more than 170,000 businesses that use Zendesk on a daily basis to support their customers. So that's, building machine learning at this scale is quite a challenge. And so the multi-model endpoint has really been the thing that has allowed us to go and build a feature like this, because it's taken away these issues of cost effectivity and allowed us, a really quite straightforward path to scaling how we serve these models in production, so we can serve that large number of customers. And it's been quite, the multi-model endpoint is a reasonably new feature, and so it's been, it's been a nice journey as well, working together with AWS on this. We've had very close collaboration over the last year or so in how we use this feature and how we can make it really work at scale for a large company like Zendesk that deals with, quite a large scale of requests, and particularly in our machine learning infrastructure. And so not only has this really solved a problem for us and helped us to build, better features for our customers, but there's also, we're quite excited about some of the enhancements that are coming up in the multi-model endpoints in the future as well, around, improving model management and helping us to take that even to the next step. So thanks very much for listening. And with that, I'm going to hand back to Syed.
Thanks, Chris. Great story from Zendesk. And thank you, folks, for joining today. If you have any questions on this presentation, please feel free to reach out to us. And also, please remember to fill out the survey. Thanks again.